Welcome to the classic probability puzzle, ants on a triangle. Imagine an equilateral triangle with 3 ants at its vertices. We label them X, Y, and Z. Here's the puzzle: each ant randomly picks a direction and walks along the triangle's edge. What is the probability that no 2 ants meet? Each ant independently chooses one of 2 directions, clockwise, shown in green, or counterclockwise, shown in orange. If all 3 ants move in the same direction, say all clockwise, no collision occurs. The ants simply chase each other around the triangle. But with mixed directions, ants can collide. Here, ant Z moves counterclockwise while X and Y go clockwise, causing Y and Z to meet head-on. Now let's calculate. Let C stand for clockwise and A for counterclockwise. Each ant has 2 choices, so for 3 ants we have 8 possible combinations: CCC, CCA, CAC, CAA, ACC, ACA, AAC, and AAA. We can derive this using permutations. Each ant independently chooses one of 2 directions, so the total outcomes are 2 to the power 3, which equals 8. Only 2 cases have 0 collisions, all clockwise or all counterclockwise. Therefore, the probability of no collision is 2/8, a mere 25%. We can generalize this to regular n-gons. For a square with 4 ants, the probability drops to 2/16, or 12.5%. For a hexagon with 6 ants, the probability shrinks even further to 2/64, just 3.125%. The general formula is P equals 2/2 to the n, which simplifies to 1/2 to the n-1, where n is the number of vertices. As the polygon gains more sides, the chance of no collision approaches 0. Thanks for watching. Like, subscribe, and comment what puzzle you'd like animated next.